Hey everyone, and welcome back to the channel. Get ready to have your minds blown, because we've got some absolutely incredible news from the cosmos. You know how comets usually have those majestic tails streaming asterisk behind asterisk them as they zip through space? Well, what if I told you there's a comet out there defying all the rules, rocking a tail that points asterisk forward asterisk? That's right, Comet 3i, Atlas has been caught on camera doing something truly extraordinary. And today, we're diving deep into these mind-bending new images and what they mean for our understanding of these icy wanderers. This isn't just a quirky anomaly, it's a cosmic riddle that's got scientists buzzing. And you're about to get the full scoop. So, let's set the scene. Comet 3i ATLAS, officially known as C2019Y for Atlas, was first discovered by the Atlas Robotic Astronomical Survey System in December 2019. For a while, it was shaping up to be quite the spectacle, even predicted to become visible to the naked eye. Astronomers were tracking it closely, excited about its potential as it drew closer to the sun. But then, things got interesting. Not only did it start to fragment, a common, though still dramatic, occurrence for comets, but new, highly detailed images captured by instruments like the Hubble Space Telescope began revealing something truly unprecedented. Instead of a conventional dust or gas tail trailing away from the sun, these images showed a distinct fan-like structure that seemed to be pointing asterisk ahead asterisk of the comet's nucleus, almost as if it were leading the charge. Now, I know what you're thinking. How on earth is that possible? Do tails always get pushed asterisk away asterisk from the sun by solar wind and radiation pressure? And you'd be absolutely right to ask. That's the fundamental principle of comet tails. The solar wind, a stream of charged particles constantly emanating from the sun, and the pressure from sunlight itself push material away from the comet's icy body, forming those beautiful, elongated structures we're used to seeing. This is why a comet's tail always points away from the sun, regardless of whether the comet is approaching or receding. It's a cosmic windsock. So, for 3i, Atlas to seemingly defy this fundamental law of physics, well, that's where the mystery really deepens. The initial images sparked intense debate and speculation within the astronomical community. Was it an optical illusion? A trick of the light? Or was there something genuinely unique and groundbreaking happening with this particular comet? Scientists meticulously analyzed the data, cross-referencing observations from various telescopes and instruments. What they found wasn't an illusion, rather a complex interplay of forces and a truly fascinating phenomenon. The forward-facing tail is the conventional tail in the sense of being pushed by solar wind, but rather something far more intricate, a consequence of the comet's fragmentation, rotation, and perhaps even its unique composition. One of the leading theories gaining traction among astrophysicists is that this forward-facing appearance is actually an asterisk, anti-tail asterisk. Yes, you heard that right, an anti-tail. While less common than the traditional dust and ion tails, anti-tails do exist, and they appear to point asterisk towards asterisk the sun, or in this case, seemingly forward in the comet's direction of motion. This phenomenon usually occurs when larger, heavier dust particles, which are less affected by solar radiation pressure than the finer dust or gases, are released from the comet's nucleus. Due to their greater inertia, these larger particles continue to follow their orbital path for a longer time, appearing to stream out in a direction opposite to the main dust tail. When observed from a specific geometric perspective relative to Earth, the comet, and the sun, these particles can project in a way that makes them look like they're leading the comet. However, with 3I ATLAS, the situation is even more complex because of its dramatic fragmentation. The comet didn't just shed a few particles, it broke into multiple pieces, creating a vast debris field. Imagine a cosmic confetti explosion. When a comet fragments, it often exposes fresh, volatile ice to the sun's radiation, leading to an outburst of gas and dust. This outburst, combined with the multiple fragments now following slightly different trajectories, creates a much more chaotic and dynamic environment around the comet's nucleus. The forward-facing appearance could be an effect of these larger fragments, or a cloud of larger debris being observed from a unique angle as they slowly disperse, giving the illusion of a leading structure. Another intriguing possibility ties into the comet's rotation. Comets aren't static objects, and often rotate as they travel through space. If 3I Atlas had a particular spin axis or an unusual rotational period, it could influence how and where material is ejected from its surface. Imagine a rotating sprinkler releasing water. The spray pattern can look very different depending on the rotation speed and the angle you ray viewing it from, while solar wind will still push everything away from the sun. The initial ejection velocity and direction from a rapidly rotating, fragmenting nucleus could create complex dust formations that, from certain angles, appear to precede the main body. It's a bit like watching a spinning dancer. Their movements create trails that seem to defy gravity for a moment. The scientific community is incredibly excited about these observations because they offer a rare opportunity to study comet fragmentation and dust dynamics in unprecedented detail. This isn't just about a weird tale, it's about understanding the internal structure of comets, the forces that tear them apart, and how they interact with their environment as they plunge into the inner solar system. Each observation like this provides another piece to the puzzle of how our solar system formed and evolved. Comets are essentially time capsules from the early days of our cosmic neighborhood, preserving pristine material from billions of years ago by studying their behavior, especially when they do something unexpected. We gain invaluable insights into those ancient processes. What's even cooler is that these discoveries are often made possible by collaborations between ground-based observatories and space telescopes. While powerful instruments like the Hubble Space Telescope provide incredibly sharp, detailed images, ground-based telescopes offer broader perspectives and continuous monitoring, allowing scientists to track changes over time. It has this synergy that allows us to build a comprehensive picture of phenomena, like the 3I Atlas anomaly. Every time a new image comes in, it's like unwrapping a new clue in a galactic detective story. So, what's next for 3I ATLAS? Unfortunately, like many comets that fragment, it began to dim considerably after its breakup, making it much harder to observe. It has since continued its journey away from the sun, diminishing from view. However, the data collected during its spectacular, albeit short-lived, show will be analyzed by scientists for years to come. The forward-facing tail or anti-tail of 3I ATLAS will serve as a fascinating case study, pushing the boundaries of our models and theories about cometary physics. It reminds us that even in subjects seemingly well understood as comets, the universe always has new surprises up its sleeve. This incredible event underscores a vital truth about science. The universe is constantly challenging our assumptions. Just when we think we have a handle on how things work, something extraordinary happens that forces us to reevaluate and expand our understanding. It has this spirit of discovery and the willingness to question the known that drives scientific progress forward. And it's why we keep our eyes glued to the telescopes, ready for the next cosmic surprise. What do you all think about this incredible comet? Have you ever seen an anti-tail or another strange celestial phenomenon? Let me know in the comments below. If you found this cosmic deep dive as fascinating as I did, please smash the like button, share this video with your fellow space enthusiasts, and don't forget to subscribe for more journeys to the far reaches of our universe. Your support helps us keep bringing you these amazing stories from beyond Earth. Thanks for watching, and I'll catch you in the next video.